Hello everyone, myself Sneha Murthian, studying in Sri Venkateshwara College of Engineering from ISC branch. Today we are going to discuss about a topic called recursion in Java. First is recursion. Here introduction to recursion in Java. First means recursion is a programming technique where a method calls itself to solve a problem. It involves breaking down a complex problem into a smaller or simpler subproblems. Recursion requires a base case to terminate the method calls. This is the introduction to the recursion in Java. Next is understanding the recursive process. First, we have to understand how the recursion process will be taken. First is recursive method have two components, that is the base case and the recursive case. First, the base case defines when the method should stop call itself. Then the recursive case defines how the method call itself to the problem. These are the two recursive methods, that is base case and the recursive case. Next one is example for the factorial calculation. The factorial of a non-negative integer n is denoted as n factorial, and it is the product of all the positive integers less than or equal to n. Then the recursive approach for a factorial calculation, that is base case and the recursive case, that is if n is 0 or 1, then we have to return 1. In the recursive case, return n multiplied by the factorial of n minus 1. Here is an example for a Java program for a class factorial. Static int factorial int n, then we have to, if n equals 0, then we have to return n. Return n factorial n minus 1. Public static void main string asks system.out.println factorial of the number 5 is star plus factorial of 5. We have to close the brackets, and for this given program the output is 5. The factorial is 5. So this is the example for the factorial calculation. The next is example of a Fibonacci sequence. First, the Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. Recursive approach for a Fibonacci sequence. Here, the base case is if n is 0 or 1, we have to return n. In the recursive case, return the sum of the Fibonacci numbers of n minus 1 and n minus 2. Here is an example. Here is a Java program that how we have to represent the Fibonacci sequence. Classic Fibonacci example 1, that is a public static void main string asks int n1 is equals to 0, n2 is equals to 1, and n3 comma I comma count equals 10. System.out.println open the bracket n plus n2 for I equals 2, that is I is less than count plus plus, then n3 equals n plus 1, n1 plus n2, system.out.println plus n3, n1 is equals to n2, n2 is equals to n3. We have to close the bracket. This is the example of a Fibonacci sequence. And the next one is binary search. Binary search is a search algorithm that finds the position of a target value within a sorted array. Recursive approaches for a binary search. Here is a two, that is base case. If the array is empty or the target value is not found, we have to return. In the recursive case, compare the target value with the middle element of the array. If it matches, return the middle index. Otherwise, recursively search the left or right half of the array. This is the binary search. And this is an example for the binary search program in Java. First, we have to define class binary search example. Public static int binary search int array. Int first, int last, int key. If last is less than or equal to first, int mid equals to first plus last to the first divided by 2. So then we have to give a public static void main string. Then we have to give a values like 10, 20, 30, 40, 50. It will take the middle number, that is of int key equals 30. Int last equals array into length minus 1. Int result is equals to binary search open the bracket, array comma 0 comma last key. If result equals -1, then system.out.println system is not found, else system.out.println element is found at the index plus result. Next is advantages of recursion. Recursion simplifies complex problem by breaking down into the smaller subproblems. It allows for the elegant and concise code compared to the iterative solutions. Recursion can handle problems with unknown or the variable depths. Now, disadvantages of recursion. Recursive solution can be less efficient in terms of time and memory compared to the iterative solutions. Recursion may lead to stack overflow errors if the depth of the recursion is too large. It can be challenging to the debug and understand the recursive code. So these are the disadvantages of the recursion in Java. And the next one is tail recursion. What do you mean by tail recursion? Means tail recursion is a special case of recursion where the recursive call is the last operation performed in a method. It allows for optimization by eliminating unnecessary stack frames. Java doesn't provide direct support for the tail recursion optimization. The example for the tail recursion is, first we have to call continuous state pass, class proxy, def int, self wrap. So these are the things which we need to do for the example of a tail recursion in the Java. Next is the common mistakes with recursion. That what are the common mistakes we will do while the recursion? Not defining a base case can lead to the infinite recursion. If we not defining a base, that will lead to the infinite recursion. Then forgetting to change the input parameters in the recursive call can cause incorrect results. We will forget, most of them will forget to change the input parameters, so that we can't get the recursive call. Not properly managing the recursive stack can result in stack overflow errors. These are the common mistakes that we will do while doing a recursion. And the next is guidelines for using recursion. Ensure that the problem can be broken down into the smaller subproblems. Define a clear base case to terminate the recursion. Make sure the recursive call progressive towards the base case. These are the things which we have to follow while doing the recursion. That we have to first ensure the problem and we have to break it down into the smaller subproblems. That we can easily find that what are the problems that were there in that program. Then we have to define a clear base case to terminate the recursion. We have to clear the base case. We have to define and we have to clear the case base to determine the recursion. Then we have to make sure that the recursive call progresses towards the base case. These are the guidelines why we have to follow while using a recursion. Next is best practices for the recursion. First, we have to test the recursive method with different inputs to ensure correctness. Then we have to document the recursive method and its purpose clearly. Use appropriate variable names to enhance the readability. First, we have to test the recursive method with different inputs to ensure the correctness. Then we have to document that and we have to use with appropriate variable names to enhance the readability. These are the best practices for the recursion. The next one is summary, that what we have learned from these slides. First one is the recursive is a powerful technique in Java where a method call itself. It simplifies complex problems by breaking them down into smaller subproblems. Recursion requires a base case to terminate the method calls. So these are the things which we learned from those PPTs. Thank you.